Hey folks, Cool18 here, and welcome to a brand new Unity 3D tutorial where we explore tile-based movement, the sort of thing you would need if you were making a Civilization-style game, or maybe like a roguelike dungeon crawler kind of thing, or any sort of tactical combat game. We are going to be working on pathfinding. You can see that here in my very pretty, beautiful little demo here. This map, the green represents sort of grassland terrain, or some sort of open terrain. These white tiles here are mountains that are impassable, and this brown area here represents, I don't know, swamp or some sort of difficult terrain that costs twice as much to go through. And if I click, I'll start moving right away. This pawn has a movement rate of 2 per turn. So if I click, say, down here, it'll advance 2 squares, and if I hit end turn, a couple more, and then a couple more, and a couple more, and then finishes it off there. The red line, I realize, is a little hard to see, and that's because I'm just using the debug.drawLine tool where you can't put in a thickness, but it was very, very easy to put in. So in this video, we're just going to be talking about theory and background. There's not going to be any actual code implemented, but I think it's still going to be pretty instructive, and you should watch. The whole series is going to be a total of 6 videos, and by the end of it, you'll be able to make this. All the code will be available on my website. If you go to quill18.com and you go to the Unity tutorials download link from there, you will be able to download the code from every single episode, including the final project. And actually, this includes some bonus content that wasn't originally covered in the actual tutorial videos themselves. Just this little animation where we slide along the path wasn't in the original tutorial. So if you download the bonus package, you'll be able to get all that. You can see that this thing likes to avoid walking through the swamp territory. The swamp costs a movement of 2. And even here, you can see if I go through, he only moves 1 square at a time through here. And if I put him, say, in this corner, if I tell him to move here, you can see he wants to take a longer path to get here. This path would technically be a little shorter, but it requires walking through a lot of swamp. And here's another good example of he actually goes 1 extra tile out of the way to get out of the swamp here a little bit faster to get to this point right there. Okay, so that's this particular demo. Let's go ahead and talk about some of the theory behind what we're going to be doing. Oh, I will point out we have already done I've done a video on tile maps before, but that was mostly different ways to render tile maps. This is focusing purely on the movement, and as such, we are starting from scratch. Everything in here is written from scratch using no external libraries whatsoever. The only thing I downloaded from the internet was the chess piece, the pawn piece over here, and that is the only thing that we are not going to make out of scratch over the next 6 episodes. Yeah, so you don't need to see the previous tile map episode. It's going to be fine there. All right, I have some slides. Look at me, slides. This is why you guys pay me the big bucks. And by that, I mean, hopefully some of you will go to the quill18.com website and maybe download or donate for your support, especially for videos like this. I find they're probably not going to be quite as popular because they're a little more esoteric than, hey, how do you make an explosion or something like that. But if this is the sort of thing you find useful, always appreciate your support, guys. Okay. So in this video, we are going to be doing square tiles, but everything we're going to do is also going to work with hex tiles. So if you're worried about that, don't worry, everything will work fine. Let's discuss a few things. Square tiles can actually come in 2 flavors. How many connections to their neighbors do they have? In other words, your characters in your game, can you just move north, east, south, and west? Or can you move along diagonals? Because that will affect how many neighbors each one of these tiles has. Or each node in the graph we're going to be constructing, how many edges will it have? To use that sort of math termy kind of stuff. Don't worry, we're going to try to stay relatively light on the math here. But it's kind of important. As it turns out, though, the code we're going to write is going to work exactly the same no matter which version we try. And actually, the code we're going to write is also going to work perfectly fine if you want to use hex tiles. The only gotcha with hex tiles is, 1, they have 6 connections to their neighbors instead of 4 or 8, right? 6 connections to their neighbors. And displaying hexes on the screen needs a little bit more work because they kind of wibble wobble. Like, you can remember this grid here using X and Y coordinates. We can say this tile here is like 0, 0. This one over here would be 3, 0. This one here would be 2, 2, right? X equals 2, Y equals 2 kind of thing. Hex tiles are exactly the same. Internally, they're represented by a 2-dimensional array in memory. And so all the code we're going to write for our square tiles is going to work for hexes. The only difference is when you actually put a hex on the screen, you have to sort of, offset each other row, and you have to use slightly different graphics for them, and then you have to make sure they line up properly, and yada, yada, yada. I'm going to include a link down below in the description box to a great web page that talks about some of the math that you would use for hex tiles to position them on the screen and just make them visually look good, and angle stuff and all kinds of nonsense like that, which is why I'm leaving out the hexes. But everything we're going to write would work perfectly fine if you decide to switch to hexes. The only thing you have to change is how the visuals are generated. Anyway, I think I got that point across. The other thing, how much should diagonals cost? This is an interesting topic because our first implementation of our pathfinding is going to be concerned with distance between tiles. In which case, technically the distance between the center tile here and say this tile over here is very clear. It's, you know the formula, a squared plus b squared equals c squared. So, excuse me, assuming these tiles were all 1 unit wide, then the distance from here to here would be the square root of 2, which is what, 1.2 something, 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 right? From here to there, that would be that distance. However, that doesn't necessarily represent the cost of the movement to this tile. For example, if our character can only move north, east, south, or west, then what you have to do is you have to use the so-called Manhattan distance to calculate the distance to here. And Manhattan distance represents the idea of driving in the streets in New York, which is set on a grid mostly. So you can't go directly here. What you have to do is go east and then south. That means to go from here to here would cost 2, as opposed to the direct Euclidean calculation, which would say this was 1.2. I think that's right. Square root of 2, I think, is 1.2. I should have checked before the video. But, and here's the other gotcha. Even in this 8-way, where you can move diagonally, it doesn't mean that the cost from here to there should be the actual Euclidean distance. And in fact, in almost every game in existence where you can move diagonally on a grid like this, to move from here to here simply costs 1, right? That's what you would expect. If you have a movement rate of, say, 3, you would expect in most games to be able to go 1, 2, 3. And so that's a little bit of a consideration. It doesn't affect our design. We're going to use a function at some point that's going to calculate out the cost to move from one tile to another. And it's in that tile, it's in that function that you could, basically pick and choose what the various costs should be. It's going to be very straightforward, very easy, but keep it in mind as you design your stuff. And then also, if you're using any sort of difficult terrain, if you've got hills or swamp or some, a tar patch or something like that that might cause people to slow down, then the cost changes based on what the tile is. And in games like Civilization, especially Civ 4 and Civ 5, where rivers exist between tiles, you can go from one tile, say a grassland tile, to another grassland tile, which has a cost of 1. But if you do it while crossing over a river, the cost actually goes up, which is kind of a weird consideration. Anyway, all things to think about. Hexes, as I said, exactly the same sort of logic, but they do come in 2 flavors. It's interesting to talk about. You can either have the flat bit on the top, or you can have the flat bit on the sides, or the pointy top, as I say over here. But other than changing how you display them, you can see here the columns are always in the same place, and it's the rows that zigzag. And here, the rows are all the same, but it's the columns that zigzag. In addition to code, the code we're going to write is going to work with square tiles and hex tiles. They're also going to work with these sort of arbitrary polygon, wibbly-wobble, timey-wimey kind of tiles that you can get in games like Europa Universalis. Here, the tiles they're basically all hand-drawn and hand-placed and defined, in some file somewhere that says, oh, here's, your borders and whatnot, and also who my neighbors are. What's interesting is that here and here, your neighbors are constant. You always have 6 neighbors, with the exception maybe you're at the edge of a map, which we'll talk about in the videos. But here, you have an arbitrary number of neighbors depending on exactly where you are. Norfolk over here only has 4 neighbors. Lincoln, Oxfordshire, Essex, and also Dogger Bay over here. It has 4 neighbors, and that's all. Whereas you can see Oxfordshire has tons of neighbors. Everything we're going to do is going to work perfectly fine with this kind of setup here. Also, and while this is hand-drawn, basically, you can also have procedurally generated terrain that looks kind of samey like that. This is a Voronoi diagram. You can check out the Wikipedia page for it. It's actually really not very hard at all to generate stuff like this. You put a bunch of points all over, and the point is in the center of these areas, and then the calculations basically define sort of these polygons. And then you end up with kind of a cool looking map. Now, I don't know of any game that uses this technique yet, except with a caveat, Civilization Beyond Earth, which is kind of odd. Civilization uses hex-based tiles, but you can put improvements on some of the tiles, including farms. And here's an example of a hex tile that's got a farm on it, and the pattern of the farms, which are all procedurally generated on the fly should be pretty familiar. It looks to me like they use these Voronoi diagrams to do their farm graphics, which, I don't know, entertains me a fair bit. All right, I think that about covers this theory video. So there will be 5 other videos, and by the end of it, you will have something that is very similar to this. Technically, the last video ends, it doesn't have this pawn piece. It still has a bit of a cube, and it doesn't have the little slide animation in there. But otherwise, the videos cover everything, and this content here, including this little slide animation that I put in, will be included on the website, quill18.com. If you go to the Unity tutorials downloads at that point, you will be able to download this exact finalized project. I didn't make the pawn piece. That is a Creative Commons file. All the information is included in the project if you want to know where that's from and who authored it. But everything else was written completely from scratch and will be available for you to download for free. Hope you enjoyed it. If you've got any questions, as always, leave them in the comments. You can also email me at quill18@quill18.com, and Twitter is at quill18. I tend to respond there pretty quickly, usually. And if you have any suggestions for future videos, please don't hesitate to drop me a line. See you next time, folks. Bye-bye.